All right, let's learn our rules for finding out the number of significant figures in a number. Our first rule is the easiest. All non-zero numbers are significant. And so if we have the number 23, as we saw with our measurement, that is 2 sig figs. The 2 and the 3 are significant. Trouble is when we have zeros, because zeros are very useful for placeholder, because sometimes we need to know how big or how small a number is. So if I just estimate, we have 60 students in here, that depends if that 60, that 0, matters or not. Is that 60 just to show you, okay, well, I know it's between 50 and 70? Or is that 60 there to show you I counted exactly 60 of you? And so we'll deal with that. We're going to see that all leading zeros are not significant. That means our dear friend 007, this number has 1 sig fig. 0.0834, this is 3 sig figs. Any zeros at the start of your number are there for placeholder purposes. They're there to show you the magnitude of the number. The 834, if we just say 834, that means 834. But that's not the same as 0.0834. If you're looking at the amount of lead in your water, are you going to say 834 ppm, which is quite high, or 0.0834 ppm, which is a better number? The small one. The zeros matter. They're very important for telling us how big or how small a number is. But they're not significant figures. The measurement there does not have to do with those zeros, so they're not significant. And it doesn't matter if there's a decimal or not. 007, James Bond, the zeros there do not count. They're not significant. We have kind of zeros in between non-zeros are always significant. 101 Dalmatians, someone has counted those, but let's say it's a measurement, 101 degrees Fahrenheit. That 0 matters. That is a measured 0. Someone has measured between 100 and 110 and found that the measurement is very close to the 100 side, so 101 is there. The 1 and the 0 are known for certain, and that other one, the last one, is the uncertain digit. So this is 3 sig figs. We have another number. This one has 4 sig figs. We're looking at the zeros in between as well as the non-zero numbers. The zeros at the start don't count. Again, doesn't matter where those zeros are as long as they happen to be in the middle. I can have 1110, 10,001. This is 5 sig figs. As long as there is at least one non-zero on the other sides, we're good. Those will be significant. And the last rule is trailing zeros. Are significant when there is a decimal. Anywhere in the number. So 100, 100 with a decimal, 100.0. These all have different significance. And those zeros there, because zeros have the options of being placeholders or actually being part of a measurement, we can measure 100 with accuracy. We could also guess 100. There are 100 pistachios in my jar. Guess. We'll see that this is one significant figure, because only the 1 will be significant there. The trailing zeros are not significant if there's no decimal. So that first number has no decimal point, so only the 1 is significant. With the decimal written after 100, we have three significants. The 1 is significant as well as the zeros, the trailing zeros at the end. And then if we have even more, we have 4 sig figs here. And that decimal can be anywhere. So even 0.1000 will also be 4 sig figs. All of those zeros at the end count. So I'm underlining the significant figures here. The 0 at the start never does. Zeros at the end do if there's a decimal somewhere in the number. Doesn't matter where the decimal is. If there's a decimal written, that means trailing zeros are significant. And so once we have learned to count the number of sig figs, we'll be able to do math. By the way, you may be wondering, well, what if we want 100 with 2 sig figs? What do we do there? Well, we have a system. We're going to use exponential notation there. This is something that's covered in algebra and all that. But if you want 100 with 2 sig figs, we're going to want to write it as the following. We are going to have a base number and an exponential term. This way, this will equal to 100 with 2 sig figs. Mathematically, the number is 100. 1 times 10 squared is 100. But this part has significance, and this does not. The power of 10 does not carry significance. So this is called scientific notation. Definitely something that we'll be working with throughout the semester. It's a great way of dealing with sig figs because you see here there's not an easy way for us to say 2 sig figs for the number 100 without using this idea of putting it into an exponent. So if this is something that's totally new to you, which it shouldn't be, but if it is, I would go ahead and just Google scientific notation because that's how we're going to be using this idea. So scientific notation is how we can get ways of exploring significant figures with numbers that may have conflicting zeros. Because we saw if there's no zero, only 1 sig fig. If there's no decimal, 1 sig fig. If there is a decimal after the 100, where we have to write the decimal, because if we write 10 point, that's not the same as 100. Would you rather have $10 or $100? So just remember, 10 is not the same thing as 100. Pretty common mistake, but believe it or not, it happens. 10 is not 100. Rather have $100, thank you very much, rather than 10. So just be aware that significant figures may require you to use scientific notation. In the next video on this topic, we're going to learn how to apply significant figures to actually working with these measurements that we've spent all this time working on how to apply.